In this video, we take yet another question on maximum likelihood estimation, this time the normal distribution. So if x follows a normal distribution with mean u and variance sigma square, and the PDF is given as 1 all over square root of 2 pi sigma squared exponential negative x minus mu squared all over 2 sigma squared. So if you have this as an PDF, you say find the maximum likelihood estimate for mean and sigma square. So we are asked to find the maximum likelihood estimate for mean and the variance sigma square. Now we say solution. The first thing to do is to take the likelihood function of this distribution. Now, if our distribution is this square root of 2 pi sigma squared exponential negative x minus mean all over 2 sigma squared. Now, we say take the likelihood function, take the likelihood. The likelihood of the given function is equal to the product sum, as I want from 1 to n, the product sum of the given function. Now, it then means that our likelihood function is equal to the product sum as I from 1 to n of 1 all over square root of 2 pi sigma squared exponential negative x minus mu squared all over 2 sigma squared. Now, if you take the product sum of this function, this is how it will come out. This is what we get. F of x mu sigma squared is equal to the first one will give us 2 sigma squared 1 exponential negative x minus mu squared all over 2 sigma squared multiplied by 1 all over square root of 2 sigma squared 2 exponential negative x minus mu all squared all over 2 sigma squared multiplied by the continuous value into 1 all over square root of 2 sigma squared and exponential negative x i's, do the first one, do the second one, x I minus mu squared over 2 sigma squared. So we then need that our likelihood function is equal to this is how to get the maximum the likelihood function. Our likelihood function can be written as 1 all over square root of 2 pi sigma squared raised to the power of n exponential negative you sum x I minus mu squared all over 2 sigma squared as I run from 1 to n. So if you take the product sum of the normal distribution, this is what we get. We get this multiplied by this, multiplied by if you continue that way, you can give us this. Now, our likelihood function is this. The first thing to do is to rearrange this properly so that it will be very easy for we to take a logarithm. So, how do we rearrange this? We move over to this side of the board to do that. We just considered in taking the likelihood function of the normal distribution. So we are reading that we can write it as a likelihood function of x is equal to 2 pi sigma square 1 all over 2, sorry, n all over 2 exponential solution of x I minus b squared as I running from 1 to n all over 2 sigma squared. So we have the 2 pi negative n all over 2 pi negative n all over 2 is still the same thing. Negative summation of xi minus mu squared as I running from 1 to n all over 2 sigma squared. So this is what we get if we rearrange it. We just rearrange. So after rearranging, it is very easy for we to take our log. It is very easy for we to take our log. So we can write take the logarithm. Take the logarithm. So we have the f of x mu sigma equal to, if you take the log of this, you have negative n all over 2 mean 2 pi minus n all over 2 mean. So if you take the log of this, you get this. If you take the log of this, you get this. Now, if you take the log of an exponential function, you have negative summation of xi minus mu squared all over 2 sigma squared. We can take this to be our equation star. Equation star because we recall it back. This is our equation star. So if it's from here, we can now differentiate with respect to mu and with respect to sigma squared. So the first thing to do is to take the derivative. Take the derivative with respect to mean. Take the derivative with respect to mean. So we move over to this other side of the board to do that. So, everything reference to me. Now, that means that we are writing as the derivative of our lead function, our likelihood function of the leading distribution, which is x into mean and sigma squared is equal to, if we take the derivative of this with respect to mean, You see that there is something like me here, so this becomes 0. So we have 0. We will also take the derivative with respect to mean here. We see that this also becomes 0 because there is no mean here. So we have minus 0 minus this minus sign. If you take the derivative with respect to mean, we have mean here. So we differentiate this. To differentiate this, we get this 2 will go back to this side to give us 2 summation as I running from 1 to n xi minus mean 2 minus 1 all over 2 sigma squared. So we can write this formally, we are differentiating with respect to mean. Sorry. Now we write this out properly. We have the derivative of our given function equal to, okay, since we are differentiating with respect to mean, we say multiply by 1, negative 1, because this is mean. So if we differentiate this from function of a function, we have negative 1 here. So because of this negative 1, it will also be affecting this to give us 2 summation as I running from 1 to n xi minus mean 2 minus 1 all over 2 minus 1 is 1 all over 2 sigma squared. Of course, this can cancel this. We can also equate to 0. If we equate to 0, we have, that means equating this to 0, we have summation of x I minus mean all over 2 sigma squared is equal to 0 as I running from 1 to n. So this can multiply this. So we don't be left with summation of x I minus mean to be equal to 0. Now we can get this here as I running from 1 to n. Now, if you take the sum of this, we get summation of xi minus, if you take the sum of the constant, we get n times that constant equal to 0. Yes. We get n times that constant equal to 0. Then we can rewrite this as summation of xi to be equal to n mu as I running from 1 to n. So if you make mu the subject, you can have mu to be equal to summation of xi as I running from 1 to n all over n, which is equal to our mu. So our mu estimate is equal to x bar, which is unbiased. So this is how to obtain the maximum likelihood estimation for the mean. Now, we will also obtain the maximum likelihood estimation for the variance, just like the question said, that we should obtain the maximum likelihood estimation for the mean and the variance. We have gotten that of the mean. Now, we are moving over to get that of the variance. Now, like I told you, from this equation start, we have to differentiate with respect to sigma squared for we to obtain sigma squared as our maximum likelihood estimate. For more on this topic, you need to subscribe to this channel. Now, we can say from equation start, which is this, differentiate with respect to sigma squared. Differentiate with respect to sigma squared. So, if we are differentiating with respect to sigma squared here, we have the derivative in f of x mu and sigma squared all over the sigma square to be equal to now. If you watch that there is no sigma square here, so here it becomes automatically 0. Now we have sigma square here. If we differentiate this with respect to sigma square, we have negative n all over 2 sigma square. Now we also have this. How do we differentiate this function? Because we can't just write it here. How do we differentiate this function? We use the partial derivative if you want. You can use the partial derivative. Or you use the quotient rule. The quotient rule of differentiation. Now, that quotient rule states that v du all over the sigma square v du all over the sigma square minus u v all over the sigma square all over v square. And this is equal to now. Let's take this to be our u and take this to be our v. Let's take this to be our u and this to be our v. So we are differentiating. Let's write it out. Summation of xi minus mu square all over 2 sigma square. So this is our u and this is our v. Now we can easily remember there is a negative sign here. So we can bring this and delete this. So we are differentiating that last part with respect to sigma square. We are differentiating the last part with respect to sigma square. Now, what is our v? Our v is 2 sigma square multiplied by the u all over the sigma square. Of course, the u all over the sigma square will give us 0. Minus, because there is no sigma square here, minus u. We have u to be summation of si minus mu raised to the power of 2. Now, the v all over the sigma square, the v all over the sigma square will have, if we differentiate this. Now, we are differentiating with respect to the sigma square. So, if we sigma square, the will go off. So, we have 2 here, just 2. So, because sigma square is just an entity, so we are differentiating with respect to sigma square all over 2 sigma square all square. So this can give us, of course, this is 0. This will give us negative 2 summation of si minus mu square all over 4 sigma square. So that's what we get. Of course, these 2 can cancel this to give us 2 here. So we can write this to be negative summation of si minus mu all square all over 2 sigma, of course, 2 times 2 here will give us what? This 2 is an entity. So we have sigma square 2. So this is what we get as irony from 1 to n. This is what we get if we take the partial derivative from our equation star. So we can easily clean this. Now, we can easily write out this properly. Then look at our derivative is equal to our derivative can be written as negative n all over 2 sigma squared plus summation of xi minus mu squared as I running from 1 to n all over 2 into sigma squared squared. Now, the next thing to do is to equate the whole of this to 0. Because we said from our maximum likelihood estimation that the first thing to do is to take the likelihood function, the second is to take the log, the third is to take the derivative with respect to any given parameter and equate to 0. So we write equate to 0, equates to 0. We are equating the whole of this to 0. We have negative n all over 2 sigma squared plus summation of xi minus mu squared as I running from 1 to n all over 2 into sigma squared to be equal to 0. So this is equal to 0. Of course, we can cross multiply. I will push this over to this other side, whichever way, to obtain our sigma squared or our variance. We move over to this other side of the board. So we move over to this side of the board to obtain that. Remember, we've already gotten the estimate for mu. And the estimate for mu is x bar. So for more on this topic, we need to subscribe to this channel. So we can write this as n all over 2 sigma squared is equal to negative summation of xi minus mu squared as I running from 1 to n all over 2 sigma squared. Of course, this can cancel this. This can move over to here to give us 2 sigma squared all over 2 sigma squared summation of xi minus mu squared as I running from 1 to n all over n. Now, this can cancel this. The whole of this will cancel this. So we are left with sigma squared to be equal to summation of as I running from 1 to n xi minus mu squared all over n. Now, from this point, we can now find the estimate for sigma squared. We can find the estimate for sigma squared. And the estimate for sigma squared exists already. Or you can write, if you square both sides, you can write our estimate for just sigma squared to be square root of summation as I running from 1 to n xi minus mu squared all over n. So this becomes our estimate for sigma squared or for the variance. That becomes our estimate for the variance. Now we can recall. We can now write out all we have gotten in finding the maximum likelihood estimator for the mean and variance. You will recall we have our mean, we got our mean estimate to be x bar, which I said is unbiased. and our maximum likely estimate for the variance to be square root of summation as xi minus mu squared as I running from 1 to n all over n. So this becomes the maximum likely estimator for me and the maximum likely estimator for the variance. So for more on this topic, you need to subscribe to this channel to get more on maximum likelihood estimation.